Micron's $250 billion memory challenge compels business leaders to strengthen chip strategy and build smarter AI capacity. You need to understand that Micron's massive $250 billion U.S. memory investment is a clear signal that the entire global AI infrastructure is undergoing a massive structural shift rather than just another technology expansion cycle. If you are building modern enterprise AI platforms, you can no longer assume that buying faster processors alone will solve your problems because memory availability has officially become your primary system bottleneck. You should note that data centers now command more than 50% of the entire global memory demand, shifting memory from a simple background component into a critical corporate asset. When you look closely at the numbers, global semiconductor sales recently cleared a historic peak of nearly $795 billion, showing you the sheer scale of the hardware ecosystem you are operating in. At the same time, you are witnessing major cloud providers scale their collective AI infrastructure investments beyond $350 billion annually to keep pace with demand. L-Impact Solutions points out that if you focus exclusively on procuring advanced graphics processors without securing your memory supply, you are directly exposing your business to severe deployment delays and poor hardware utilization. You are facing a reality where artificial intelligence workloads, like large language models and multimodal systems, consume dramatically larger memory footprints than any traditional enterprise application you have run in the past. To put this scaling challenge into perspective, you need to prepare for the fact that AI context lengths are currently exploding at a massive pace of nearly 30 times every single year. You also need to realize that the average memory content packaged inside an individual AI server has officially doubled within just the last 3 years. If you look at the broader market, L-Impact Solutions highlights that total global AI infrastructure spending is on track to rocket past $1.5 trillion by the year 2027. You must realize that approximately 35% to 40% of that massive $1.5 trillion capital pool will be spent directly on memory technologies like HBM, DRAM, and advanced enterprise storage layers. To help secure your operations against overseas disruptions, Micron is explicitly targeting a goal to manufacture 40% of its total global DRAM output inside the borders of the United States. You should track Micron's massive domestic expansion roadmap, which stretches across high-tech manufacturing ecosystems located in Idaho, Virginia, and central New York. When you calculate the timeline for these advanced projects, you must factor in that a single modern semiconductor fabrication facility now requires a capital investment exceeding $15 billion to $25 billion. You also need to plan your technology timelines carefully because these advanced megafabs regularly require construction periods extending well beyond 4 years before a single commercial wafer is produced. To anchor the broader material supply chain, Micron is backing its core manufacturing push with an additional $3 billion investment dedicated entirely to domestic semiconductor supply infrastructure. As part of this targeted $3 billion integration strategy, you will see $500 million poured directly into strengthening domestic silicon wafer manufacturing plants. You will benefit from the stability created by Micron securing a vital 10-year strategic supply agreement to lock in upstream chemical and material inputs. According to official data compiled by SEMI, you should expect global 300mm memory equipment investments to climb to a historic $52 billion mark during 2026. You need to brace for continued capital competition because this equipment spending is projected to expand by another 11% to hit $57 billion in 2027 as manufacturers bid for restricted tool allocations. Even with this unprecedented capital spending, you must realize that global memory manufacturing capacity is only projected to creep up gradually to roughly 4.1 million wafers per month in 2026. You will see that gradual capacity growth edge up only slightly higher to approximately 4.2 million wafers per month as the industry moves through 2027. This sluggish output expansion happens because high-bandwidth memory takes up to 2 to 3 times the physical wafer space of standard DRAM, which naturally lowers the total volume of chips you can get from a factory floor. You should also recognize that leading memory fabricators are choosing to upgrade their existing cleanrooms to advanced nodes rather than building physical factories from scratch, keeping your near-term supply incredibly tight. When you look at the employment landscape, Micron's sprawling U.S. expansion program is projected to create and support an estimated 90,000 direct and indirect jobs across the economy. However, L-Impact Solutions warns that a severe, industry-wide shortage of experienced process engineers, material scientists, and precision technicians could stall your project timelines regardless of how much capital is spent. You need to look beyond the technology sector and realize that memory consumption is accelerating fast as financial institutions deploy generative AI for complex fraud detection and real-time risk management. Your strategy must account for healthcare systems rapidly integrating AI-assisted clinical diagnostics, which continuously pull massive imaging datasets through local memory banks. You will find that modern manufacturers are driving up component demand by deploying predictive maintenance networks across automated production floors. Even regional and national governments are entering the market, expanding memory usage through the rollout of large-scale, AI-supported public services. You are likely relying on hyperscale cloud operators to rent your AI computing power, which means you are directly competing with thousands of interconnected, high-bandwidth memory systems. Because this infrastructure spending is so concentrated among a few cloud giants, you face higher allocation risks if component shortages strike the Tier 1 data center networks. To protect your returns on invested capital, L-Impact Solutions recommends that you immediately replace your traditional, short-term component procurement habits with long-term strategic capacity planning. You should actively avoid the trap of purchasing your memory hardware only after your specific enterprise AI projects receive formal corporate approval. Instead, you need to aggressively establish 3-year to 10-year rolling supply agreements that guarantee your access to DRAM, HBM, and advanced NAND storage assets. You must diversify your hardware footprint across multiple distinct suppliers and geographic regions to insulate your workflows from sudden regional trade disruptions or factory downtime. You need to expand your baseline infrastructure investments well beyond compute chips to include the entire hardware ecosystem, including specialized substrates, power management units, and optical networking links. Your corporate board should explicitly strengthen AI capital governance by using lifecycle return on investment metrics, rather than just looking at the initial hardware sticker price. You must stress test every single one of your upcoming AI project models under a tough scenario where specialized memory prices spike anywhere from 15% to 30%. Your financial models should also assume that your physical infrastructure deployment schedules could easily stretch out an extra 12 to 24 months due to macro equipment delays. You must prepare your budgets for potential allocation shortfalls where your available memory volume drops significantly below your original planned operational capacity. Before you rush out to buy more expensive hardware, you should order your engineering teams to prioritize model optimization and aggressive workload scheduling. You can dramatically lower your data center operating costs by implementing advanced memory compression, model quantization, and memory-aware software design. You will find that leveraging retrieval-augmented generation allows your systems to maintain peak business performance while keeping actual DRAM utilization highly efficient. L-Impact Solutions advises that national governments must coordinate industrial policies across the whole semiconductor value chain, ensuring that local power grids and water systems can support these massive new megafabs. You should join collaborative forecasting networks that share clear demand insights across manufacturers, cloud providers, and enterprise customers to prevent sudden shortages. You need to treat semiconductor supply chain resilience as a permanent, board-level strategic priority rather than a temporary fix for seasonal hardware shortages. You can use predictive analytics platforms to continuously monitor your internal inventory coverage, wafer allocations, and global logistics performance. By tracking these metrics early, your procurement teams can easily secure critical manufacturing slots months before market shortages impact your operational timelines. You should establish a strict corporate mandate that prevents your business from relying on any single country, vendor, or advanced packaging provider for your core hardware assets. You must recognize that long-term production efficiency relies heavily on stable regional infrastructure, such as high-purity water supplies and highly dependable green energy grids. Your governance frameworks should explicitly require your executive teams to deliver detailed, quantitative AI infrastructure risk assessments every single quarter. You ought to maintain a solid cushion of 6 to 12 months of physical inventory coverage for all your long lead strategic hardware components. You should enforce a minimum operational target of keeping your active infrastructure utilization rates consistently above the 75% efficiency threshold. You must verify that your third-party data center providers maintain strict cybersecurity compliance levels that comfortably exceed 99%. You need to run regular operational stress tests that simulate severe geopolitical disruptions, unexpected energy shortages, and sudden financing cost spikes. You must keep your research and development initiatives completely consistent across shifting market cycles to avoid falling behind on next-generation architectures like DDR5 and CXL memory. You should realize that the next phase of global AI competition will heavily reward your operational preparedness and supply security, far more than just aggressive, uncoordinated corporate spending. By weaving a comprehensive semiconductor strategy directly into your corporate governance, you will actively defend your long-term shareholder value. Ultimately, you must treat memory capacity as a core competitive asset today if you want your business to achieve sustained growth across the rapidly expanding global AI economy. Will your AI strategy collapse without securing memory supply? Comment below. For more strategic analyses, visit our business consultancy website, link in the description below. Thank you.